Good morning to all, and welcome to another session of Java programming. And in this class, we'll discuss about Java classes. Okay, so you know that classes are the foundation of object-oriented programming. Okay, they define the behavior and the attributes of an object. Okay, object which every object represents a real world. So here we'll see that how these classes and objects are handled in Java, how Java takes care of its classes. So let us have a revision of or let us discuss what is this class and objects are. Okay. Now, a class provides template for an object. All right. So yes, that is true. That a class provides template. So when we say template in terms of some properties, some behavior, okay, that an object performs. So in real world we see many objects, but the class is one of the way to describe a group of objects, okay, or describe the properties or the nature of a group of objects. And in that way, we can group a set of objects into a particular class, because depending upon their behavior and attribute. So definitely, when we have a class defining a set of objects, so this set of objects share the similar property. That is very essential. Okay. So because of the similar property and behavior, okay, we can define a class. Okay, or template. Okay, a template says that, okay, what is the generic thing? What are the generic things available with all these objects? Okay, so when we have a template, these templates help to create an object. So when a object is created, looking at this template, we can understand that, okay, this object will have these properties, and this object will behave this like this, or this will have a method like this, can call this. These are the methods. Okay, it can call. All right. So that's how we define a template. So class provides a template visualization of an object which is generally created at the runtime. Okay, so that line, the second line indicates that an object is an instance of the class and it is runtime. On the runtime, the objects come to life. You can say object doesn't have any role when it's object. So, but class doesn't exist in the runtime. Remember that the classes are used to create object during the runtime. Okay, so an object when is created, okay, during execution, so it may go under many states. So a state of an object is represented by the data fields, or we say generally the properties or attributes, okay, but the properties or attribute with their current values. So we may have objects whose state changes from time to time depending upon the operations performed on it, or depend upon the operation performed on other fields or other objects. Okay, it happens. So object state changes. So state changes indicate that the data fields or their properties, their values changes. Okay, so a state is represented by its current value. What is its current state? That means you find out what are the set of current values are assigned to its data fields or to its properties. That defines the state of an object. Say for example, I'll take an example of let's say a pen. Okay, a class is a pen. Okay, so class is a pen that, okay, we can have the property like the pen, the model, pen of the model. Okay, let's the brand name of the pen. We say the Reynolds. We have used Cello. Okay, there are many brands. So one of the properties is Cello. So when it is created, these properties, so when a pen is manufactured, that becomes the a pen of some company, some brand. Okay, so Cello, let's say Cello is one of the property which doesn't change. So when the pen is finished and it is get rejected, till that time the name Cello remains the same. Okay, so name is one of the property, or brand name is one of the property, or one of the property which represent the state of an object that doesn't change with the time, or that may not change, okay, at all. Okay, you can, or if at all somebody takes the pen and rebrand it, okay, then only the name changes. But come to one of the property or one of the data, the attribute of the pen, that is the refill label. Okay, we can have one property called refill label. Now, initially, when the object is created, one pen object is created, okay, the refill level is full. or we can say 100%. And during operations, when a operation is performed, its state changes definitely, so it will be updated. So whenever we see that okay, the refill level changes, we can apply the behavior or the methods or any many member methods we have defined, we can update its refill. So the refill level is a state that may change. So depending upon what value of refill level is currently having with an object, so that defines the state of the object. So let's say we say state of an object, okay, it's a cello pen with 100% refill. Second state is the cello pen with 70% refill, cello pen with 20% refill. This is how we define the state of an object. You can take this same example for any other objects. Okay, we can define that. So where the state is defined by the current values. We will see in our programming language we hardly change the object state. Okay, because we mostly work with the static objects. Okay, objects, so not static object means object with the static values. Okay, so and definitely when it comes to the changing of a state, the behavior of an object is defined by the method, and this behavior is allow this property to change. Okay, so the actions or which are the behavior, they actually play the role to change the state of an object. So now let us come to this is very clear about what is a class and a object and its state. So let us see how we can define a class in Java. This is a generic format, I can say a generic template for defining a class in Java. Okay, so the object or the C++ program learner who have already gone through C++, you know that the syntax is almost same. Only minor differences are there here. So a class definition begin with the keyword class, with the class name that you provide. You try to always follow the object oriented naming convention, that is okay, always init cap, that is called init cap. So you have a class name that might contain multiple words, so each first letter of each word should be capitalized. Okay, that is the convention used for class name in generic object oriented program. Doesn't matter any programming language. Okay, so it is independent of the programming language. So that is the convention used. Then the type, where the type indicates the data type, and the instant variable one. So these are the different variable one. For an instant, we're defining the variable. So there can be n number of variables, or n number of, we can say, the properties or attribute, okay, or the data fields. That's a class. Okay. Then the methods define the behavior. There are two parts for an object. Okay, what are their properties, what are their behavior. So behavior is defined by the actions or the method. So in Java, instead of function, we generally use the term method in Java. Okay, as I already told my previous lectures. Okay, so we define the methods. Okay, they are simple functions. If we learned C or C++, we can see that. Okay, so there's some take some parameter, perform some action. So we can have more than one or more number of methods for a class which operates on the data. Generally, they are not independent. They actually act upon the data field of the class. Okay, let's come to example, and mostly you will see that I will take this example, this box example throughout my lecture as an example. Okay, to demonstrate various features of Java classes. Okay, so we have a simple class here. So the C++ users, okay, you can easily distinguish the difference that the class in Java does not end with a semicolon. Okay, so it simply begins with the open curly brace and ends with the end curly brace. All right, so and we can define all the members. So we have three data members here, or data fields in the class, that is the width, height and depth. Okay, all are of type double type. Okay, we're taking maximum into account. All right, so this is how the object is the class is defined. All right, then come to the creating object during runtime. Okay, so here only I'll show you that. Okay, there is in my the upcoming slide. Okay, we see that how why we have to why this is has to be a new. Okay, so always in Java, remember that we create a new object. Okay, forget about primitive type. Okay, any object type, whenever, it doesn't matter whether it's a library object or your own user defined class class objects. Okay, so objects are always created or okay through new. Okay, object are created and initialized through new. Okay, new operator. So new operator will actually create, okay, an object in the memory. All right, so my first object name is box1. So I create box1 actually. Okay, the box1 equal to new by using new operator, new box. So whenever I will do this, this object is created in the memory. So you can see that. Okay, so the box1 is created. Okay, this is how we imagine that a box1 is created like that. Okay, and each field of this object box1 can be accessed through dot operator, that okay, we have already discussed. So dot operator generally for the accessing member. So any member, width or height or depth, whenever I need to access it, I can access through dot operator. Okay, box1 dot width represent the width of the object box1. Box1 dot height represents the height of the. So we can access this data members, data fields. Also we can modify this, modify these data members wherever we require. It is required. Okay. So similarly, the two objects are created. So box2 equal to new box, box3 equal to new. So new operator are to be used while creating an object of the of a class. Okay, now we are the same example. We are modifying, we are changing, we are updating, or we are updating the state of an object. Okay, okay. So this is the class we have just seen. Okay, and the main, I have created the same way, three objects, box1, box2, box3. So when I created this, so memory is allocated. Okay, so when comes to these three lines, so it's showing that when these three lines are executed, the state of the box1 changes. Okay, box1 dot width is equal to 10. So we assigning the value 10 to the width, assigning 20 to the height, assigning 15 to the depth. So initially it was none. We can say nothing. No value was assigned to it. So the state is now that the width, height, and depth of the box1 are 10, 20, 15 respectively. Okay, so by assigning the, modifying the data fields, so as you told, we can change the state. Similarly, we can see that, okay, when these lines will be executed, okay, I've just not demonstrated here. I have only demonstrated the first part, okay, how it makes changes in the box1. Okay, so when these three lines will be executed, similarly, the data fields of the object box2 are going to be updated with 12, 30, and 20 respectively. All right, so this is how we can do the updates. Okay, then we can just we are calculating the volume. Okay, we are in the main, we are defining a variable volume, and yeah, volume equal to, for box first we are calculating the volume for box1. Okay, so multiplying width, height, and depth, we are storing it in the variable vol, and we are printing the volume of the box1. Okay, then again we are using the same variable to store the volume of the box2 by accessing each data field. You can see that we are accessing box2 dot width, box2 dot height, and box2 dot depth. So at this moment, in this line we are storing the volume of the box1. In this line we are storing the volume of the box2, and we are printing it. Okay, so let's see the demonstration of this program so that we can easily understand. So this is how we can add, okay, we can update the data fields of any data field of a class. Okay, and we can access to dot operator. So this is very similar to the C++ syntax. Okay, other than you have to make sure that you are not adding by mistake a semicolon at the end of the class name. Okay, so let's see the demonstration of this. Increase size. Okay, it will be good. Right, so I think this class is box demo. So let me see the class name. Yeah, so it will calculate the volume of two objects and print it, right? So Java box demo. Okay, so box 1 volume is computed as 3000 and box 2 volume is computed at 7200, okay, or 7200. Okay, so you can see that. So this is how we access the data members of the any class we have defined it. Okay, so you can see that when these lines are executed, okay, the box 2 is updated. Just I have shown you the demonstration. All right, now as I was telling that, okay, the declaration okay, of object, or creation of object involve definitely two steps. Okay, we can do it in two steps, so we can combine them into a single step. You have just seen an example where, okay, it is a combination of these two steps. Okay, in the previous example you can see that we have done box 1, the object name box 1 equal to new box. It's a combination of actually these two steps. Let us discuss these steps. Number 1, box, okay, the class name box and box 1. Okay, actually what happens here, we declare a variable, an object, okay, declare a reference to the object. Okay, it's simply a variable, but till now box 1 doesn't hold any memory. Okay, box 1 just a variable created, yet not initialized in the memory, where, okay, it will hold a reference to this memory. It only happens when you use box 1 equal to new box. In this step, actually the new operator dynamically allocate memory to the object, okay, of box, okay, and return the reference to it. So only after this particular statement, okay, the box 1 is going to hold a reference to a memory where an object is actually created. Okay, because they share the same type, so box 1 has the ability to hold the reference to any box type object. Okay, so here actually we can see that, okay, we already know that the box is a constructor. Okay, we are not only creating the we just by new operator is actually dynamically allocating the memory, but at the same time we are also invoking the constructor. Okay, because we can also perform some initialization task when an object is created. Sometimes we need to initialize them with the values. Okay, some data fields to be with the values when it is created, so that is done. So here we can see that we are passing a constructor. It is also known as a default constructor. Okay, so a constructor defines what actions when object of the class is created, what action to be taken. Okay, what occurs means actually what action to be taken or what type of statement to be executed when an object is created. Okay, so we are not only dynamically allocating memory using new operator, but also we are calling a constructor to do some initialization task, perform some actions when object is created. So now what is the result of this? So definitely what happens here, we know and this, let me come to the C++ user. They generally think of like a copy constructor kind of thing, right? Definitely we have used the concept of copy constructor. Okay, a constructor, okay, the data of one constructor, one object is copied into the data fields of other object. Okay, so here we created an object b1 with new, definitely, so memory is allocated for the object b1 and a reference is written to it. So b1 holds a reference to the this memory area. Now when we do b2 equal to 1, what happens? Can you guess? Is it that b2 copies, okay, memory is created and b2 holds the all the data are copied to the b2's memory? Actually it is not. You can see that. So here the assignment of b1 to b2 did not, okay, allocate any memory or copy any part of the original object. Okay, not even nothing, not even copied. Okay, remember that. First of all, it is not created. B2, no object is created for B2 because new is not used. Okay, so But what happens here, it's simply a reference. Okay, b2 is another reference to the object which is already been created, and already b1 is holding a reference to that. So you are creating another object variable which just hold a reference to the already existing object. So it's just like, if you remember the reference variables, okay, so it's nothing but a reference variable. We can also call that the b2 is a reference variable, okay, to other b1. Okay, so any changes that is made through b2 will also affect both through b1 and b2 is going to affect to the object, the actual object. So it doesn't matter what you are changing, either through changing the b1 or b2, it is definite, because both holds the reference to the same object. You must remember this concept. Okay, now adding methods. Till now we have seen that we have performed some actions on now in the main function only, but let us see, yeah, we can add some actions or the behavior part of a class. Okay, this we have seen the attribute parts, we have seen the attributes, we have modified the attributes. Okay, so behavior parts. So we have defined a method here to compute the volume. Instead of computing volume in the main, we have know that every box has some volume value, so we can compute the volume by using. So there is a method here. Void indicates that there is no return type, bound doesn't return anything. Okay, it simply displays here. Because we can return also, if required we can return, but here I am trying to just print the volume within the method only. All right, so yes, so it prints the volume is print the result of width multiplied with height with multiplied depth. Okay, that's all, 2 lines only, 2 statements within volume. Okay, and similar to accessing the data fields, we can call any member method, okay, or any class member method through the object, through dot operator, by with reference to an object. It has to be called through reference to an object. Okay, so it depending upon which object is calling, okay, that data are accessed or modified. Okay, so here we are not storing anywhere, but we are simply accessing width, height and depth to compute the volume and print it within the volume. Alright, so you can see that. So first we have created 2 objects with using new operator. So box1, new my box1 equal to new box, my box2 equal to new box. Alright, so done. Then we are updating the state of my box1, okay, by changing the value of width, height and depth. Similarly, we are assigning the values to the width, height of depth of the box2. Okay, then we are invoking the volume method by using my box1 dot volume method, my box2 dot volume method. So these two are going to again do the similar task as the previous example. We have seen that, but we are performing the same thing through a method. We have defined a method. Now again I'll for the C++ user, you already acquainted to C++ user, you can easily mark one thing, is that I'm directly accessing all the data fields within the main function, which is outside the scope of the box class. Okay, and without any hesitation, it is successfully I am able to do that. So it clearly mentions that if we can declare a variable, they by default become a public. Okay, but we'll discuss about how these public methods are accepted, how much public, okay, means whether it is outside the class or where till what point they can access, while we discuss the access specifier. But for the timing, we can easily come to an inference that any variable that is declared, simply declared, okay, or declared within the class, okay, are public. Okay, so they can be accessed outside the class. Okay, we'll extend this discussion later on. Okay, so here is an example of defining method. So again, method defined, so it becomes public. Okay, no need to, and if you C++, you know that we have to put explicitly within the public part. Okay, but here by default it is public, so no need to put these fields in the. So this concept should be clear between Java's declaration and Java member declaration and C++ member declaration. Okay, so all are public. Everything can be accessed directly outside the scope of the class. Now we can also have methods with the parameter. Here is a demonstration of defining a method, okay, for a class with parameters. All right. So here the method I have added is the set dimension. So yes, I don't have a I'm just creating, while creating an object, before computing volume, instead of no, accessing them directly outside, yeah, better to don't not allow the access outside, okay, not to access them outside. So I've just gone for a temporary plan, that is, let us define a method, okay, to set the values, okay, instead of directly accessing the fields. Okay, so here is a method. I've added a method here. We can pass, it is accepting 3 arguments, okay, to assign the respective values to the data fields width, height and depth. Okay, so W, H and D are the 3 arguments passed to the set dimension or set dim, okay, and these are assigned to the data fields width, height and depth. Okay, so now I don't have to access the data members directly in the main function. What I'm going to do is that I'm going to call setDim to assign the dimension for the object box1 and box2. You can see that this is done through these 2 methods. Okay, then computing the volume. Okay, you can, so you have to make sure that whenever you are invoking this method, you are invoking through an object, and whenever we are assigning here the W width equal W, so W is assigned to the width of the invoking object. So my box 1. So when this statement is executed, the 10, 20 and 15 are assigned to the width, height and depth of the object my box 1. Similarly, when my box 2 dot setDim is invoked with the parameter 3, 6, 9, so 3, 6 and 9 are assigned to the width, height and depth of the object which is invoking, that is my box 2. So you should know that. So here we can directly refer to all the data member within any method, any data member of the class, any data method in the class, and they will reflect. So where here inside this method, okay, the member methods, the variables, the width, height, depth refer to the width, height of depth of the invoking object. Okay, so no need to access through the object here, so they can access them directly. So they always represent the data member of the invoking object, or the object which has called this method. Okay, so then we compute the volume. We know that now you are calling the volume. Now you have modified the volume method a little bit. Now volume method returns a value. Okay, simply it compute the volume and returns the volume. Okay, so return type is double. So when the volume is invoked, we are storing the return value into a variable volume, then we are printing the volume. Okay, very simple. So this is an example of a method which accept arguments. Okay, very similar to the C or C++ methods. Another example. Okay, we have you can see that there are 3 data members. One is channel and a volume level, and an on, okay, the state of TV. So TV has properties, a channel, what is the current channel, okay, what is the volume level. So 3 properties I have just only considered. Okay, so whether it is on or off. So initially, okay, I can say that you see an example here that we can initialize the value. Okay, we can initialize the instance by in the class directly. Okay, so this is how, okay, the default values when an object is created, these are the default values assigned. Okay, so when an object is created, so by default the channel will be at 1, the volume level will be exactly 1, and TV will be off. Okay, so the on status will be false. Okay, so using the method turn on, we can change the status on to true. When you say turn off, it will change the status to false. By means the data member on is assigned to false. Then you set channel. Okay, a new channel number is given. We are checking that whether this first of all the TV has to be on. Okay, the on value has to be true, and the new channel should be within the channel, whatever the channel range is. We cannot assign a channel as 220 when the TV can take only 100 channels. Okay, that's the point here. So a checking is done here by using the control statement. You see that on, the TV must be on first. The channel should, the new channel number should be greater than 1, equal to 1, and less than equal to 20. Then yes, we can change, we can update the channel data field with the new channel value which is passed as an argument. Okay, then set volume, right? Set volume. So we can also set the volume. Again, volume level is maximum 7, minimum is 1. Again, for that the TV has to be on first. Okay, television has to be on first, so it should be on and the volume level should be within the range. Then we can update this new volume level to this to the current volume level. So volume level is updated by set volume, channel is updated by set channel, and yeah, we can do channel up. Okay, so you can press, we have generally a plus button, minus button, right? So these two methods, public void channel up, public void channel down, these two are implementing your plus and minus button of your remote, right? Okay, similar, channel up and channel down, so plus channel, minus channel. Okay, so here we are making sure the channel is less than 120, then we can do channel plus plus. Okay, channel down means it should be greater than 1, then we can do minus 1. Okay, minus minus. Okay, if it is not there, we can, that will be exactly, if it is equal to 1, then it will always remain 1, it will never change. Okay, that's the point. Similarly, volume up, volume down. Okay, so basic basic behavior of a TV, the properties, how the TV changes, we are demonstrating through this example. Okay, so we have how many methods here? We have 1 2 3 4 5 6 7 8 8 methods acting upon the 3 properties, okay, or the 3 data fields that is been defined for describing a TV, okay, a television. Next, we'll discuss about the constructors, okay, which are generally the essential parts of while creating an object. Okay, as we have discussed that in one of the previous example, that when an object is created by using new box or a new the class name, all right, it not only allocate memory, it also invoke the constructor. Okay, by default the default constructor, okay, which generally if you don't define, then the Java compiler takes care of that. Okay, but it allows us to define or initialize, okay, whenever required, depending upon our requirement, by using our constructor, using user defined constructor. So generally the constructors have same name as the class, okay, and in which it resides, and it's syntactically similar to the method. Okay, this is the definition of constructor, how we define constructor. It is defined just like method, the only thing is that its name is same as the class name. Once defined, constructor is automatically called immediately when the object is created. So objects constructors are automatically called when during creation. Okay, just before, and it is executed just before the new operator completes the line, the new operator completes. Okay, so and constructor have no return type because they implicitly return returns a class, okay, object, right? So the return type matches with the class type. Okay, so that's why there is no return type mentioned for the constructor. Let's see an example. Okay, so the first, we generally call this a default constructor. So we define, okay, a constructor here, then the class name matches with that, so box. So the method name is box, no parameter. Okay, we are initializing with our own value. So we are printing here constructing box, and we are setting with the width, height, depth value to 10. Okay, so some initialized values, instead of keeping the variables without any value, okay, undefined values, better to initialize them with some value. Okay, and we have defined the volume function. Okay, let's see that how they are invoked. Okay, so now previously we don't have in this constructor. Okay, so what happens when an object is created, the width, height, width, depth values were not assigned, unassigned values. Okay, now whenever the object is created, their values are, okay, their values by default, okay, this constructor is called, and it's set to width 10 for each width, height, and depth. Okay, we can also change the values by using parameterized constructor. So this is a default constructor, this is parameterized constructor. Okay, so whenever we need to know, I know the value. So parameterized constructors are really helpful when you know in advance that what is the initialization values, or when an object is created, what are initial values are going to be. If you have that idea, okay, that you have this information, then it is always beneficial to use parameterized constructor. Okay, so parameterized constructor not only they create the object, okay, but they also assign with some value. I mean, the database will be assigned with the values which can be passed to the parameters. Okay, so they have parameter, okay, or they have the arguments. That's why the name comes parameter constructor. Okay, here is an example. So box, okay, the same as the class name, and it accepts some argument. There are 3 arguments because we have only 3 fields. So these 3 fields are initialized by the value provided by the user. All right. So W, H, and D. So width, W is assigned to width, H is assigned to height, and D is assigned to depth. Okay. So while constructing the box object. So, and this can be invoked by passing the parameter. If you don't pass the parameter, it will understand that you are invoking the default parameter. So in that case, all will be 10. But when you pass some parameter exactly matching with the number of arguments or number of parameters and the type of argument, this parameterized constructor going to be invoked and going to assign 10, 20, 15 to the my box one. So my box one not only created, okay, memory is allocated by creating this object, but also initializing its width, height, and depth value to 10, 20, and 15 respectively. Okay, this is the benefit of using parameterized constructor. Let's have this demonstration of this default constructor and parameterized constructor. Here it is. So I have saved it as box constructors. So Java. So let's see the program. So Java box constructor. Okay. Java box. Okay. Constructing box. Okay, 2 objects are created, but things are little difference here. I have to differentiate it. Okay. Okay, let us do that because we are not able to distinguish which one is called. So let us make a little change here. Yes, 2 objects are created with parameterized constructor. Okay. So it is saying that constructing box. Okay, that's it, just to differentiate the value. Okay, so you can see that 2 objects are created via parameterized constructor. Okay, by passing the values directly, so I don't have to invoke any other method to assign them. Okay, so the objects are created and assign the value, and we can compute the volume directly. Okay, that's it. So we can easily now visualize it now. Actually, it is calling the constructing box. So first object is created via parameterized constructor. Second is created, then it compute the volume and print the volumes. Return the volumes and print in the main. Okay, this is the how parameterized constructor works. Okay. Next comes to this keyword. Okay, sometimes the method need to refer to its object, okay, to its own object, or the object which has invoked the method. Okay, so this is really essential inside the methods which are being called. Okay, the methods of a class which are so. This keyword, which is also for C++ user, we already know that this keyword is already there in the C++. Okay, it can be used inside the any method to refer the current object. When I say this current object, means the object with reference to which this method has been invoked, or the object which has called this method at this moment. Okay, and this is always reference to the object on which the method is invoked, and can be used anywhere as a reference to to an object of the current class type. Okay, so especially when we need it. So this is the scenario where we really need this. Okay, so sometimes we may pass the parameter with the same name as the data fields. Okay, it is allowed, no problem. But when I refer a width here, width equal to 10, okay, height, which width? Definitely, whether are you referring to the because they are also the local variables of the constructor, of your parameterized constructor. So which width? So to make it clear, to explicitly refer to the width of the data field and width argument, okay, so we can use this here. So this, okay, keyword will help here. This was a pointer in C++, but here this is a keyword, as simply we can use this dot width to represent that, okay, this is the we are trying to refer to the width data member or data field of the current object, the object which has recently which has invoked this method, okay, height of this object, okay, and so this object or the object which has invoked. So it clearly distinguishing that this the R values are width, height and depth are the arguments, okay, and the L values are the data members of this object which has invoked this class. Okay, this is the use of this. Okay, so most of you know about this, so I think I don't know. So whenever you need to explicitly refer to the object, okay, which has invoked this method, inside the method use this, okay, instead of the box name. Some people by mistake write the box my box 1, my box 2, which is the object name. So here this is to be used, okay, that this keyword has to be used. Then comes to very important point in Java, that is garbage collection. Okay, so as we know that was one of the best property of Java, that automatic memory deallocation technique, okay, or automatically memory is deallocated. We don't have to bother about that, and that method, that particular technique is called garbage collection in Java. Okay, so when there is no reference to an object exists, suppose you have created an object but no one is referring to this object. So what happens means we don't have any variable, any object variable referring to that memory area, okay, that we have created. So object is assumed to be no longer needed and that memory is reclaimed. Okay, and in there is this is not there is no explicit need of destroying, like calling of a method like free. There is no free method here, or there is no delete here, just like in C++. Okay, so garbage collection only occurs sporadically, if at all, during the execution of your program. Now remember, during your execution of program, it hardly happens the garbage collection is performed. Okay, it hardly happens. Okay, sometime, and if at all it is required, that happens. Okay, whenever maybe we do some explicit action that will need to perform a garbage collection, then only it will do. Otherwise, it is not done. Now, how the garbage collection is to be performed? What is the approach? Because let me tell you, the garbage collection is one of the topic to be discussed in detail in our compiler design. Okay, while designing compiler, this part is to be defined, that what is the algorithm to be used for garbage collection, what is the interval of garbage collection, or it is to be always to be done at the execution end of the execution. So that is there. So different Java runtime will implement different approach of Java collection. So not necessarily you will find the same way of garbage collection for the all JREs. Okay, whether in Windows platform or Linux or Mac platform. So that may vary. Okay, or may vary with the versions also. Next comes a special method that is called finalize method. Okay, so it is an alternate term for destructor in C++. In C++ we use destructor, okay, and here it is finalize. So it defines an action to be performed when object is destroyed. So we perform some action when object is created. So in the reverse part, we want to perform some action while the an object is destroyed. Okay, means its memory is reclaimed, okay, or deallocated. All right. So this mechanism also called as finalization. Okay, executed when an object is just to be reclaimed by the garbage collector. Okay, so this method is invoked when you have, if at all, defined in your class exactly at the moment when the memory of the object is reclaimed by the garbage collector. Okay, to add a finalizer to the class, we use this keyword finalize method. Okay, so most generally it is protected, and void will come to discuss about protected later because it is related to the inheritance. Okay, so that it can be used by the classes which are inheriting this this method, this particular class. Okay, so we'll come to that later. So it has to be generally protected, void, then finalize, the keyword finalize. Okay, not any name of the method, and you write your code here. Okay, a simple example, you see that. Okay, so here I'm just putting some 2 lines. I don't have many complex tasks here. It's very simple classes. So here when the memory is reallocated for all the objects that I create, it is going to print the box object destroyed. Okay, inside finalize of box. That's all. 2 lines should be printed. I have defined. Okay, so you can do some. You can see some examples here. But mostly because this is called after the execution, you may not see the output. Okay, maybe you see the output after the execution after the completion of the program. Okay. So there are methods to call finalize explicitly, but definitely not suggested. It's not recommended to suppose something while doing the execution, when I was just about to complete the execution, we may call finalize. Okay, explicitly. That is not recommended. Okay, but there is methods to call. There is a process to call the finalize method explicitly. Don't try to do that. Okay, so I think let us break up our class into 2 parts. So let us end here the first part of the discussion of Java classes, and second part we have many things like overloading the constructors, okay, and overloading the methods. We'll see many examples related to that. So for today, let us stop this session here. That's all. Thank you all.